All right. Okay, that was our homework. Here we go. We'll come back to that. The zeros of a function are the x-intercepts. It's the points where the function crosses the x-axis. And x-intercepts occur where y is equal to 0, because if you're crossing the x-axis, then you have not moved above or below it, have you? Okay, so the other pair, or the other coordinate of that ordered pair, is always 0. Well, the way that we're going to find the x-intercepts is we are going to have to factor to solve. Okay? Now, the first thing I want you to realize is that there are not always going to be x-intercepts. And I'll show you some examples. If I have a parabola that opens up with its vertex above the x-axis, will it ever cross the x-axis? No. The lowest point it goes to is still above the x-axis. So in this case, that is the case of a parabola that does not have any x-intercepts. Where would a parabola, or where would the vertex be located if it was opening down and it would never cross the x-axis? Under the x-axis. Anywhere under the x-axis, okay? The vertex could be here. Could be here, opening down.
Which one is positive?
This is positive, the top one, opening up, okay? Now, if a parabola's vertex is located above the x-axis and it's opening down, how many times will it cross the x-axis?
Twice.
2 times. If the vertex is located below the x-axis and it's opening up, how many times will it cross? Twice. So we have possibilities where there is no x-intercept. We have possibilities where there are 2 x-intercepts in a parabola. How do you think there would only be 1 x-intercept in a parabola? Yeah, but we're dealing with these right now. They can go sideways, but those are x equals y squared. Right now we're dealing with y equals x squared. If the vertex itself sat on the x-axis, because the vertex is the highest or lowest point. So if the vertex itself sat here on the x-axis, whether it opened up or down, there's only 1 x-intercept. So if you find the vertex of a parabola and it is on the x-axis, that is also your what? Your x-intercept. Okay? All right. Before we continue, I want us to look at the effects that changing the A, B, and C terms have to a parabola. Okay. What you see here is your standard parabola. Okay? Notice the equation under the blue heading on the right-hand side. This is f of x equals x squared. There's no x term, there's no constant term. Which means the y-intercept is 0. The vertex is 0 because negative b and b is 0. 0 divided by anything is 0. Okay? This is your standard parabola. Yes. Watch what happens. This is my a term. Right now, a term is positive 1. Watch what happens to the parabola when I increase the a term. What happens? It gets skinnier. Okay? Now, I can't make this do fractions. It does do negative numbers. When I make it -1, it took the standard one, just flipped it upside down, right? Now it's opening down. As I make my negative numbers bigger, notice the parabola is getting skinnier and skinnier and skinnier. I can't make it do fractions, but let's think for a second. If A gets bigger, a bigger whole number, makes it skinnier, what do you think would happen if I went from 1 to 1/2? It's going to make it fatter, okay? So a whole number A means, and the bigger the number, means that your parabola is thinner and thinner and thinner. Fractions for A, the smaller the fraction, the fatter your parabola is. All right? So our A term determines how fat or skinny this thing is and which direction it goes in. Watch what our B term does. I'm going to go back to a basic parabola, which I'm there, okay? All right, watch your B term. What's happening? It's shifting the vertex around the origin, or around the whole graph, actually. Here we go. It's moving again. All right? What if it was opening down? Watch what happens. Does it change how fat or skinny it is? It just changes the location of the vertex. Okay? It moves the parabola around the graph. Watch what happens when I change the C term. Does it change the fatness or skinniness? Does it move the vertex around the graph? Not in circles, but it moves it up or down. All right? So, huh? Oh, okay. Yeah, it's by 2s. All right? Now watch. Let's take this. Let's make our A term 3, which means that it's going to be what? Skinnier than this. Oh. Let's make our B term -6. And y'all want to move it up the y-axis or down? Down the y-axis. So do I need to make C positive or negative? Negative. Negative C moves it down the y-axis. All right? What if we wanted it fatter? Smaller number. Oop. What if I wanted it to flip the other way?
Negative.
Negative numbers.
Wait, go back. So if you have 0 at A, it's a straight line.
It's a straight line. Because if A is 0, this x squared term is gone. So all you have is y equals mx plus b. What does that remind you of? It's a straight line. It's the equation of a line. Okay, that's why yesterday when we said the function is in this form, A cannot equal 0. You have to have an x squared term there. Okay? All right. Now, let's look at some examples of what we're going to be doing today. Solving our zeros of our function by factoring. And we are on page 301, 302. Okay. If I wanted to find the zeros of this function, number one, this is a parabola because it is a function and it has an x squared term. All right? The zeros of the function are the points where it crosses the x-axis. Yes, ma'am?
Negative parabola only has to have an x squared.
It has to have an x squared. It doesn't have to have the other two. Because remember, your standard